Here's our next example. So we're going to talk about our main steps through a problem where we need to solve a rational equation. First, we find the common denominator. What is the LCD? In order to find the common denominator, we need to make sure that each of our denominators is factored, and it looks like they are. The x minus 1 we cannot factor further. The x plus 3 we cannot factor further. This 2, it's a whole number 2. We can't imagine that it's a 2 over 1. But having this 1 is not going to change our LCD because multiplying it by 1, we still arrive at the same answer. So I hope that you're seeing for the LCD, we need to use x minus 1, and we need to use x plus 3. And let's jot that down here for our LCD. X minus 1 times x plus 3. Okay, zoom out. All right. Next, what do we do with the LCD? Since it's an equation, it's not about build all those fractions up into new fractions that have that LCD for the denominator. It's about multiply every term of this equation by the LCD to see how things cancel. So I'm going to just do a little bit of a rewrite, and I'm even going to leave myself a little bit of space to write in the LCD that I'm going to multiply to every term. This one times x minus 1 and x plus 3 over 1. This one, let's zoom in there, the writing is getting a little bit tiny. X minus 1 times x plus 3 over 1. And do not forget about the right side of the equation. Don't forget about any of them, is what I should say. But a whole number like 2, it's maybe the most common place to go off path, is forgetting that this guy even needs to get the multiply by the LCD. True, it's our choice to multiply everything by the LCD to see how things cancel, but it needs to get the multiply. Whether there's something there that we're going to cancel or not, in order to be a legitimate move, we need to multiply it to every term of this equation. So next, let's spot the canceling. From our first term, x minus 1 with x minus 1, those are canceled. In this middle term, it's x plus 3 with x plus 3 will cancel. And on the right side, there's nothing to cancel. So I'm going to rewrite what I currently have after things have canceled. From this first fraction, we're left with a 2x times, that is the x plus 3. From our middle term, it's this positive 2 times x minus 1. This plus, I'm really just bringing down that plus. So plus 2 times x minus 1, that factor that did not get canceled. And on the right side, there's, well, everything is left over because nothing was canceled on the right side. So there's our equation right now. We don't have any fractions, but we definitely are not at our solution. All we've done is clean this equation up. The next thing is to do all the multiplies that we have to do. And we've got a few. We've got 2 distributes, or maybe 3 distributes, and a FOIL that we have to do. So we'll just go slow. Starting all the way on the left, we're distributing this 2x. So I have 2x times x and 2x times positive 3. That's giving us a 2x squared plus 6x. In the middle, distribute this positive 2, gives us a positive 2x minus 2 equals, ooh, a big one here. We're trying to multiply 3 things together, the 2 and the factor x minus 1 and the factor x plus 3. If we are going to multiply 3 things together, you basically pick 2 to multiply together and then multiply the third one in. So what I mean by that is, I'll pick the tough one to do first. I'll pick the FOIL. That's going to be an x squared plus 3x minus 1x minus 3. That's x squared plus 2x minus 3. But don't forget, we also had this 2 out front that needs to get multiplied in. So my right side is really 2x squared plus 4x minus 6 equals 2x squared plus 6x plus 2x minus 2. Nice long equation. It's starting to look like it is a quadratic because I see some x squares in the equation, but they're both the same. They're both 2x squared, and what that means is if I spot x squared, my approach is let's get all the terms onto the left side and make it equal to 0 on the right side. And when I start to do that, like I say to myself, I want to cancel this 2x squared off the right side with a minus 2x squared, and if I do it to one side, I have to do it to the other side. Observe what's going to happen. We'll get our cancel on the right side, but also we get the cancel on the left side. So at first it looked like it could be a quadratic, but in reality, it's going to turn into a linear equation. That's good news because linear equations are usually quicker to solve. On the right side, what are the terms that we're left with? We have a 6x plus 2x and a minus 2. Well, we've got some like terms, 6x plus 2x, 8x minus 2 equals 4x minus 6. A nice linear equation, so I'm going to work to get the x terms onto the left side and number to the right side. So a minus 4x to cancel the 4x on the right side there. And I'm left with 8x minus 4x, positive 4x minus 2 equals negative 6. A couple more steps to solve this linear equation. Let's add 2 to both sides. There we get our cancel. 4x equals negative 4. And finally, divide by 4. And we're looking at x equals negative 4 over 4. That's a negative 1. We shouldn't end the problem right away. If you remember, there was something very particular that we did with the last example that we have not done yet with this problem, and that is about, well, what are the invalid answers? What would be answers? Different terms are used. They're sometimes called extraneous or invalid. And those answers come from what number in place of an x would give us a 0 in the denominator. So here I'm looking at x minus 1 in this denominator. If that x was a positive 1, 1 minus 1 would be 0. So x could not equal 1. If we worked through this problem and our answer at the bottom had x equals 1, we would have to say there really is no solution. There's another number that would be no good, and it comes from this denominator, x plus 3. We don't want that to equal 0, so if x was a negative 3, negative 3 plus 3 would equal 0. So from that denominator, we have another bad answer. X could not ever equal negative 3. Now, for an answer to be bad, it just has to make one of our denominators equal to 0. So if you're thinking about x equals 1 and saying, well, hey, over here 1 plus 3 equals 4, and that's fine, definitely. But the fact that it would make a 0 in any denominator means that it is a bad answer for the whole problem. So we have two numbers that would be bad answers for this entire problem. Now let's take a look at what was our solution. We worked through this problem and came up with x equals negative 1. And that's going to be a fine answer. It's not a positive 1. It's not a negative 3. So there is our answer for this problem, x equals negative 1.